Hey guys, this is Bob. Welcome back. We are on video number 2 in our Forced Induction Series of Superchargers. We're talking about centrifugals. This is the second video in the centrifugal set. And we're talking here with Eric Radzins from ProCharger. Hello, Eric.
How you doing?
Welcome back, man.
All right.
Yeah, so we, if you guys missed the first video, go back and watch it first, or none of this is going to make any sense. The first video, we discussed a bunch of questions related to centrifugals and just superchargers in general. So if you guys missed that, make sure you go back and watch it. We're basically picking up halfway through, and we're going to kick off with a question for Eric, which is, can you go too big on the supercharger when it is really just a belt-driven turbo, as the internet likes to say?
Yeah, no, it is a belt-driven turbo. No, you actually can have. It's not necessarily too big, like wrong, but you're gonna miss out on some of the benefits. With the different blowers we have, the wheels are designed to do different things. Some of them move a lot more air at a lower RPM. Others move a lot more air at a higher RPM. It's no different than turbos. There's a lot of, like people used to call it a diesel turbo, off of like a tractor, versus some of your modern billet turbos that spin at a much higher RPM.
Sure.
So, yes, you don't want to have such a big blower that you're trying to slow it down to make such a little amount of boost on your application, because otherwise you could miss out on quite a big
under the curve
and mid-range.
Right.
So kind of the same as a turbo, a little bit different because it is belt driven. So where a turbo you'd have a big lag period before it would come in and light off, where ours you just kind of have like a natural lack of boost during that area.
Sure.
Where you could have it if you had the proper sized unit.
Right.
Some and other things are just what a guy's doing with the unit, and making sure that he doesn't have too small of a unit, because unlike a turbo you can keep telling it to make 24 pounds, 26 pounds, 20 pounds. Well, eventually it just stops increasing.
Right.
Can't move any more air. With the blower, a guy might not necessarily see that same effect as easily because he's got a mechanical drive on it. So he's going to keep turning it. So what a guy would see is he would see the boost number might keep increasing, but unless you're on a dyno or at the track to where you can see a mile per hour gain, he might not notice that even though you're going up 4 pounds of boost, you might have taken more power to turn it and not really gained anything.
Right, because it's no longer efficiently moving in the air at that point.
Correct. So so really it comes down to just like a turbo or anything else, you want to make sure you have the unit that's properly matched for what you're trying to do.
Okay, so next question is going to be twins or single in relation to superchargers. Twins or single?
I think I was waving up one.
Yeah, right. Yes, you were last time.
Yes, so we're fortunate enough that we can make units from 100 horsepower to 3,500 horsepower now. Obviously, it's a mechanically driven device, so if you doubled the amount of gears and bearings and shafts inside of something, you now increase the amount of load and friction and stuff like that. So really the idea is always go with one as far as a supercharger goes, because even from a standpoint of a mechanical loss, it will be less than having two.
Oh, it makes sense.
So say your car is going to make 2,000 horsepower, well, instead of having two blowers trying to do 1,000 horsepower worth of work, just get the one for 2,000 horsepower and you'll end up the same. There are a few guys that are doing twins and learning what it takes to make them work, but really there's very few, if not only one person that's got it quite figured out. There's a lot more aerodynamic issues that go into play when you're mechanically driving two compressors that are basically fighting each other to do work, but that's a whole other topic. So.
Right. Another day.
So in other words, just pick one.
Pick one. I have only seen the duals on BMW M5 V10 motors, where guys have basically a split intake manifold. They're essentially two intakes and 5 runners, 5 throttle bodies on each. And then they put 2 blowers and they go straight into each of them, as opposed to driving just one large inlet, or one large plenum.
Right. So I guess what's going on with that is one thing, the blowers that they're using are very small, so it's hard to have one blower make the correct power level that they're trying to achieve. So basically they're by necessity having to use 2 of them.
Right.
but they do work okay because the motors are almost inherently separated at that point. Since they're separating the intake manifold, the
Plenums, yeah.
the left side of the motor doesn't really know what the right side of the motor is doing. So really, what they did is they properly sized a supercharger for half of the size of the engine.
That makes sense. I have to look at it further, but I think last time I saw it literally looked like two different plenums. I could be wrong, but it's kind of what it looked like. All right, so basically your answer is stick with a single. You can get what you want out of a single, less losses, easier. They're not going to fight one another.
Absolutely.
Yeah, that makes sense. So it's definitely different than a turbo in that regard then.
Yes. Well, because if you had to have a turbo the size it would take to...
Right.
You'd have...
Such lag.
Tons of lag.
Yeah,
so.
That makes sense. That makes perfect sense. So that kind of leads me to wastegates. I've seen some guys running wastegates on blowers. What's that about?
Okay, so I mean, they do work. It seems that it kind of comes in waves. The trend on the internet, like, 6 months you'll have a ton of people doing wastegates, and then they kind of get away from doing it, and then all of a sudden everybody starts doing wastegates again. So It's kind of been going on for probably the last 10 to 15 years. Really, if a person is doing that, they need to understand what is actually happening. So when the wastegate opens, yes, it is bleeding boost. What it's actually doing is increasing the airflow of the blower, because instead of it now going to a motor and being compressed, it is now going out into the atmosphere. It's like opening a door to your house while your air conditioner is on. Now it's trying to air condition the world, as my father would put it. So what happens is the horsepower it takes to turn the blower does go up significantly.
Okay.
So for guys that are trying to use it for traction reasons and stuff like that, they're kind of getting two things out of it. One, there's a lower boost pressure in the motor, so less power. And two, it takes more power to turn the supercharger, so there's less power going to the wheels in the first place mechanically. If a person's going to do it, I would say don't try to chop off any more than a pound or two, if that, because after that point it's kind of diminishing returns. And I think what a lot of guys find eventually is that just having the blower properly set up, the right boost curve, and if you're doing it for traction reasons, doing it with timing, usually ends up
a little better
in the long run. So
and something like that, the guys could go with a different like maybe like a variable ratio blower.
Yeah. Oh, absolutely.
That might make more sense.
Why the I1 exists.
Okay.
So
that makes perfect sense then. So instead of just playing with a blower that maybe is too big, or that you're having issues with spool up rate, for lack of a better word, you're going to go back and try a different blower, which would be something more like a variable ratio.
Correct.
Yeah.
Yep.
Yeah.
So again, does it work? Yes. Is it ideal? No. Do most people that do it eventually learn that it kind of is a tuning nightmare and kind of a thing? Yeah,
sure.
Most likely. A lot of guys just kind of figure out that it'll eventually go just as fast by leaving it alone.
Right.
Going with other methods. So.
Well, I didn't have this as a question written down, so maybe I'll throw you a curveball. But you spice up a little bit. What do you think of blow-off valves as terms of selection, setup, those sorts of things, and can they have an impact on the system overall, other than their intended purpose?
Yeah. Okay. That's actually pretty interesting. So, we make four valves now total. The one of them that we use standard across the line with the kit just uses a butterfly style actuator. And I know the internet is very used to, I keep saying the internet like everybody's on the internet.
Right. Well, they all are, pretty much.
It is
young guys, old geezers, you name it, they're all there.
They're used to like more the pop-off style, like a turbo. But the guys have to understand that there is a big difference between a blow-off valve and a bypass valve. When you're talking about spring pressures and things like that. With the supercharger, you literally just, if you're trying to make boost, it needs to be shut. The second your foot is coming off of it, it needs to open. And it needs to do that as fast as possible and get rid of as much air as possible. You're not trying to keep anything in a tube, to keep anything spooled or spinning. So our standard butterfly valve, even though it looks different than I think what most people are used to seeing, it's the same concept of why you have a throttle body on your car. Is it's very fast to actuate, and once that throttle body is flat open, you have a hole where air is moving straight through it unrestricted. So instead of a pop-off valve where air is now coming up, hitting a valve, and having to make a 90-degree turn, the straight through is actually outflows
A pop-off,
left
yeah.
turn.
Right.
Yeah. So we actually, on our bigger race units, we do still use the standard pop-off style just because of the pressure levels that are involved in the flow. We don't want to bend blades, you know, kind of like guys on big race cars can bend throttle bodies and things like that in odd situations.
Sure.
And then our latest valve that we came out with at PRI is now the Pro Race valve, where what it does is it's actually got some really trick stuff going on the inside of it, so that the hole, I think I want to say it's 3 inches, can flow more than anything out there on the market. We tested all of them, so I do know what they flow. And the spring inside of it is only to keep it shut when the car's off, so like, you know, to make sure dust doesn't get in or debris or anything like that. And all the rest of the valve's control is handled by boost and vacuum. And the way it works on the inside is if you put, say you got 30 pounds of boost in your car, there's actually over 60 pounds of force holding that valve shut.
Oh, wow.
So we had to come up with something for these guys that are running really high boost levels, but then might have a very big pressure differentiation from, well, even on a turbo, from a compressor outlet to what's actually in the intake manifold.
Okay.
Without adding a big giant spring shoving it down. Because the bigger the spring, the slower it takes.
To actuate.
The work it takes to overcome that. And if you don't have race cars that have big camshafts and don't have a lot of vacuum, aren't really that good at pulling vacuum to open something. So the new valve is really cool. So I have people, if they're interested in seeing more about that, they can give us a call or email us, or I'm sure it'll be on our website here.
What's it called?
But it's a real neat piece.
What's it called?
The Pro Race valve.
Pro Race valve.
Pro Race valve. And it's basically, we needed, now that we built Superchargers that can handle 3,500 horsepower, we needed to have bypass valves that could handle that same amount of airflow and do it very fast. So again, like I said, guys aren't bending throttle blades, and blades aren't sticking open for a fraction of a second and things like that. So
it makes perfect sense.
It's just a progression of where motorsports is going. We needed to make sure that there was a valve to match it. So
well, it kind of leads me to the next question for you then, and really it was, when should I upgrade to a larger blower, but also when should I upgrade to a larger blow-off valve or bypass valve?
I would say guys can call in, figure out when that moment is. Our standard valves are actually good to probably about 700-ish horsepower. You know, any street applications, things like that. There's a couple different things we can do to change sounds, because most people are more interested in sound changes than actual like what is it going to do performance wise.
Wouldn't that fall into the category of like poser? I mean, that can't be.
It just is what it is, man. Some guys want a really loud blower, some guys want a really loud blow-off valve.
I gotcha.
Some don't want to hear anything, no matter what. They don't want to hear the blower, and they don't want to hear the bypass valve. So I get it. I totally understand.
Sure.
I want my race car to be loud, and I want my street car to not make any noise while I'm driving.
I get that. I totally get that.
So really, that's more of what it is. I would say anything up to 700 horsepower, 750, our standard stuff's fine. Our race valve, not the Pro Race, but our race valve is probably anything from that 750 mark to about 1500 or so. Anything around, I would say 1500 and above, you should either have 2 of our race valves or move into that single Pro Race valve.
Okay. And in terms of blower size, so let's say I start out like every guy starts, right? First they get a cold air intake, then they get headers, and they're like, I need a supercharger, some type of forced induction. So they start and they get a P1, and they're an LS guy or even a 5.0, Mustang guy. At what point do you guys say, whoa, okay, you need to move up to the next one? Is there a stage, like a horsepower number, or how do you guys measure that?
Yep. Okay. So on our website, there's a chart that kind of tells the horsepower numbers that the blowers can achieve. I guess the beauty of a supercharger is you can get one a little bit bigger, so like than what you need, without having any real downfalls. I mean, to a point, we talked about it earlier, you can go way too big, but within reason. So like a guy with a turbo that might want 67, the horsepower of 67 millimeter would give him, but he eventually would want to get to where like a 76 would be, but he doesn't want to have the lag associated with that. Since we don't really have that issue, a guy could get like a D1SC, and he can turn it down a little bit. And the good thing is he can just keep using pulleys to keep turning it up.
Sure.
So eventually, if you're either out of lower RPM, max RPM, or you've realized you've hit the flow point where she's not going to flow anymore, that's when you need to move to the next
Sure.
step and blower. So again, that all comes down to anytime a customer calls in, we want to know what's their build right now, what's your goals in the future, and things like that. Because the last thing, we don't want anybody to buy a blower and then all of a sudden 6 months down the road,
Right, yeah,
buy a completely different one. So,
right. Yeah, that makes perfect sense. So you're kind of looking at it from like an airflow perspective. Like, man, how many pounds a minute are we flowing? What's your goal? And that sort of thing to properly size.
I'd say it's probably similar to a fuel injector.
Right.
If a guy's planning on doing a build where he could do a 60-pound injector, but he knows that some way down the road a 100-pound injector might be the way to go.
Sure.
Well, the 100-pound, you might as well get it out of the gate.
Right.
But you wouldn't want to get something like a 1500.
Yeah.
That's overkill.
Sure.
So you can go a little bit bigger, but you don't need to make a huge jump.
Okay, well, that makes sense then. Last question for you. We get this question all the time, so I'm gonna, force this one on you too. Intercooler versus non-intercooler. Guys wanting to buy a cheap system and just get in. I mean, I usually tell them, look, just suck it up, wait another month, save some money, and get an intercooler. What do you think?
Absolutely. Whether it's our intercooler, I'd love for someone to have our intercooler. We spend a ton of time perfecting them, I guess, would be the word for each application, for fitment, power levels, cooling ability, things like that. We spend a lot of time running the road course here locally and literally just doing road course testing, which is about the worst thing you can do for air-to-air intercooler.
It is.
We do drag strip testing as well. So like our C7, we offer 2 different intercooler models for it. A vertical stand-up intercooler, your common, for guys that are drag racing or half-mile racing, because it gives the best cooling ability, but then due to the small radiator in that car, you cannot run that intercooler long duration road course. So we actually came up with a laydown intercooler option for that car, and then we utilized the airflow coming underneath the car to actually suck air through the intercooler core. And so that way it didn't change the handling or aerodynamics or anything of the car. But I guess that goes back to, you will always, no matter what, make more power with an intercooler. And then there's guys out there going to say, well, I'm going to run methanol, so I don't need an intercooler.
Right.
Again, even with methanol, you would make more power with an intercooler. It's just that at that point, it might be a little bit diminishing returns at the level that those are at.
Because of cooler, denser air.
It doesn't matter what fuel your car is running on. Cooler air is denser air is more horsepower. Period. End of story is the way it is.
If you had to tell someone, like, 1 or 2 reasons why they shouldn't buy the cheap Chinese, intercooler from eBay, we get this a lot. I know you get what you pay for, and I tell them to stay far, far away. What do you think of that? What's some of the actual, hardcore reasons that you would want to stay away from the cheap stuff?
Well, number one, everything we make is here in the U.S., so I'm a huge supporter of trying to keep as much motorsport stuff here.
Absolutely.
So that's number one. Number two is, and I guess, I got nothing wrong with a guy trying to do a budget build and stuff like that. If you do buy an intercooler from an unknown source, meaning like not us or not an intercooler specific company, that's what they do.
Reputable intercooler company, yes, right.
Correct. Make sure you test it. Make sure you know what your inlet temperatures are and your outlet temperatures, your inlet pressure and your outlet pressure. And even though your buddy might have bought the exact same intercooler from this place that's on eBay or wherever it is, in 6 months from now, that doesn't mean the part that you bought is the same as his. And I've seen this trend quite a bit.
Came on a different boat.
Literally, that's exactly it.
I've seen it, man.
I'm not saying, and so some of them might work really, really well for your buddy's combo, and then you wonder why you're down 100 horsepower compared to him.
Right.
So,
pressure loss, pressure drop, all these issues of construction quality.
Absolutely. So, I don't know where they're made from, but there's a lot of people here that are just brokers for the product, and the product isn't always the same.
Right.
So as long as you do your testing, you can end up with a pretty darn good budget unit
combo.
But I would just make sure to do the testing so you know what you got. So nobody wants to put an intercooler car and then find out it's got a 5 pound or 7 pound or 10 pound pressure drop. So
yeah, I was gonna say. So what would you
just take it off?
What would you tell them to do? You tell them to put a boost gauge before and after? Was it the best way of doing it?
I mean, a lot of guys that it seems that they get a little scared because they're like, oh man, I have to drill and tap the intercooler and put a fitting in it. No. You know the little like 3-inch coupler you probably have with your tube connected there?
Sure.
Just poke a hole in one of them, have a spare one, poke a little hole, put a little nipple on it, stick your vacuum line on it, run a boost gauge, watch what it is compared to you know, your gauge in your car.
Yeah.
So
sure.
Whether you run a blower or a turbo, I'd highly suggest doing that.
Yep. So you're measuring your pressure before it goes in the intercooler, and then also when it comes out. What is a good drop to see? What would you expect? 1 or 2 psi?
Less than 1.
Less than 1.
No matter what.
Okay.
I mean, that's what we strive for on, like, you know, our racing applications or power levels on our kits. But we rate them up to a certain level. You know, if it's like up to 800 or we say it's up to 1,000, we would like to see less than a pound pressure drop across.
Right.
Because the more pressure drop, that's just the more work the blower
has to do.
It's doing.
Yep.
That means that's more heat coming into the inlet side of that, and obviously, you know, just not good in general. But yeah, so really, we push the limits of air to air about as far as you can go. I mean, we got customers making 1,400 to the tire and 1,600 to the tire now on air to airs.
Wow.
So which is
crazy.
Like,
yeah, it is.
There's a lot of. I mean, horsepower is heat, so there's a lot of heat to get rid of. So for full-blown race applications, I think you might see a couple air-to-water options for us, for those guys that are trying to make 1,500 and above.
Right.
But for street stuff, we try to stick to the air and air because it's simple.
Right.
It works, it's effective, and consistent.
Yeah. Less stuff to go wrong. Less intercooler pumps.
Absolutely.
Absolutely. Well, thanks for talking with us today, Eric. We appreciate it very much.
Absolutely, man. It was a good time.
Absolutely. And we might catch up back with you again later on in the series when we talk more specifically about intercoolers, piping, and things like that. So
that'll work.
We appreciate it very much. Thanks, man.
All right. Have a good day.
You too.